Hey, what's up? This is your old pal, Mr. Cook, and we are working on the Unit 7 extra review. We just got through the first 20 problems. Now we're working on these last, like 6 problems, yeah. So we need to have our double angle and also our half angle formulas, and also looks like our sum and difference formulas as well. So just have like access to those and you should be all right. I have them on my computer screen, so I'm going to be scrolling up to work on those. Okay, so this one says to find the sine of 105 degrees. So I can find the sine of 105. It's not on your unit circle, but I can find it because I know that 2 of the unit circle values do add up to 105. And I can use those to add the values together. So the sine of 105 is the exact same thing as finding the sine of 60 plus 45. So this is a case where I use the sum and difference formulas, and I in particular find the sine of a sum of angles. So the formula for that looks like this. It's the sine of u plus v is equal to the sine of u times the cosine of v plus the cosine of u times the sine of v. And then, your two values, u and v, are the 60 and the 45 there, so you just plug them in. So this becomes the sine of 60 times the cosine of 45, and then plus the cosine of 60 times the sine of 45. Now, all these values are available for you on your unit circle, so you should know the exact values, and that's what you should use. Do not just plug them into your calculator because we want the exact value for these. So the sine of 60, if you use your calculator, not your calculator, geez. If you use your unit circle, is going to be the square root of 3 over 2. Cosine of 45 is going to be the square root of 2 over 2. The cosine of 60 degrees is going to be, which one is that? That's 1/2. And then the sine of 45 is square root of 2 over 2 as well. So if we multiply straight across, square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times the square root of 2 is square root of 2. 2 times 2 is 4. Since they have the common denominator, we combine them together. So square root of 6 plus square root of 2 over 4. And you can't add these together, so you just leave it as is. That's your answer. That's the exact value of the sine of 105 degrees. So similarly, we're going to use tangent of 165. So they give us a hint. 165 is 210 minus 45, so you can use that. This is the same thing as saying the tangent of those two numbers subtracted, so 210 minus 45. So now you use the tangent difference formula. So the tangent difference formula is, again, should be in your notes. It's written out like this: tangent of u minus v is equal to the tangent of u minus the tangent of v over 1 plus the tangent of u times the tangent of v. So again, these are unit circle values, so you should be able to find the exact value. So the tangent of u is the tangent of 210 minus the tangent of 45, which is the tangent of v, over 1 plus the tangent of 210 times the tangent of 45. All right, well, tangent of 210, so let's see what that is. That's going to be positive square root of 3 over 3. And then tangent of 45 is 1 over, and then it's 1 plus square root of 3 over 3 times 1. So we've got square root of 3 over 3 minus 1 over 1 plus the square root of 3 over 3. And then, you're supposed to rationalize the denominator, but if you just wrote it out like that, you're good to go. I'll do some of those rationalizing the denominator ones on the group work, so let's just leave it like that. That's as far as you need to go. Just plug it in and make sure you know your unit circle values, basically. All right, next, cosine of 285. So they tell us that 285 is 330 minus 45. It's also some other stuff, obviously, like 240 plus 45 and, a bunch of other things. But we just want to get some practice with one of these difference formulas as well. So cosine of 285 is the same thing as saying the cosine of 330 minus 45. So I use the cosine difference formula. And I'm not going to write it down. You can look it up. But it's the cosine of 330 times the cosine of 45 plus the sine of 330 times the sine of 45. So then use your unit circle once again. The cosine of 330 degrees, that would be, let's see, square root of 3 over 2. Cosine of 45 is square root of 2 over 2. The sine of 330 is negative 1/2. And then sine of 45 is square root of 2 over 2. So then we get square root of 6 over 4, and then minus square root of 2 over 4, and that gives you square root of 6 minus square root of 2 over 4. And there's your exact answer for the cosine of 285. The next one is a simplified expression, so we're supposed to take this and simplify it, and obviously it gives us a hint saying that this is a sum and difference formula. So if you look on your sum and difference formula sheet, or in your notes, when you have the sine times the cosine plus the cosine times the sine, that's going to be the sine of u plus v. So all we got to do is just, use that formula, and then it changes into sine of u, which is 8x, plus the sine of, the sine of 8x, which is our u value, plus v, which is our 2x over here. So then if I just combine these two like terms, it's the same as saying the sine of 10x. So that'd be our simplified expression, just using the formulas. And remember, all of these formulas that we have here, the sum and difference formulas, those are given to you on the test, so you don't have to memorize them. Just make sure you know how to use them, especially for a problem like number 25, because it tells us that we need to use the difference formula for cosine, and then from this information we need to construct our triangles for u and then also for v, so we can find all the information that we need. So the cosine of u minus v, if you use the formulas, is going to be the cosine of u times the cosine of v plus the sine of u times the sine of v. Okay, that's just straight from your formulas. We're given some of the information, like they give us the sine of u, it's negative 5 over 13, so I can replace that sine of u with negative 5 over 13. They also give us the cosecant. Well, if they give us the cosecant of v, they really gave us the sine of v, because the sine of v is equal to the reciprocal of that, 3 over the square root of 10. So I can write that in for the sine of v, 3 over square root of 10. But it doesn't tell us anything about the cosines, so we need to find the cosines. And to find the cosines, this is where you got to draw one of those triangles. So it tells us that the angle u is between pi and 3 pi halves. So that means that it's going to be located in quadrant number 3. So what I do is I draw a little quadrant 3 like this, and then I draw a triangle, and one of the sides has to be the x-axis. So there's my right triangle. And then I put the angle in there, so the angle is u. The sine of u is negative 5 over 13, so the opposite side is negative 5 because it's pointing downwards. 13 is the hypotenuse. And then I can use Pythagorean Theorem to solve for the missing side. So negative 5 squared plus x squared equals 13 squared. You might have already seen this. This is going to be a Pythagorean triple. It's going to be 12. And since it's pointing over to the left, it's in the, on the left side, the x value is going to be negative, so that's going to be a negative 12. So if I need to find the cosine of u, I can really easily just use this triangle to find that. So the cosine of u is going to be the adjacent side, negative 12, over the hypotenuse, 13. So that's what I can plug in over here for the cosine of u, negative 12 over 13. Last thing I need to find is the cosine of v, and that's where I use this information. So v goes from pi halves, or 90 degrees, to pi, which is 180. So that puts it in the second quadrant. So I draw a triangle for that one as well, second quadrant. And then my angle is v right here. And then they give us the sine. So sine is 3 for the opposite side, square root of 10 for the hypotenuse. So then I probably would want to use Pythagorean Theorem here to find that missing side. So let's see, 3 squared plus my missing side squared is equal to the square root of 10 squared. So 3 squared is 9, square root of 10 squared is 10. So if I subtract 9, I get b squared is equal to 1. And that means that my side is 1. And since it's pointing over to the left, make sure that you put a negative on that. Okay, always be conscious about what quadrant it is in, so you know what your x and your y values are. They're going to be negative or positive based off of the quadrant. So if I need the cosine of v, it's going to be the adjacent side over the hypotenuse, so that's negative 1 over the square root of 10. And now I can start, multiplying, because this is the hard part. The rest of this is pretty easy. Just multiply straight across and combine like terms. Negative 12 times negative 1 is a positive 12, and then 13 times square root of 10 is 13 radical 10. And then minus negative 5 times 3 is 15, and then 13 times square root of 10. Common denominator, so I do 12 minus 15. So that's going to be negative 3 over 13 radical 10. And then you can rationalize the denominator, obviously, but you just leave it like that. There is your cosine, so that's the answer for that one overall. Now for the last one, find all the solutions in the interval, and then it's cosine of 2x plus sine of x. Okay, well, this is a solving problem, so it really should have been with these ones from number 16 and number 19. But this is like a dead giveaway as to what I'm going to do. This is just a double angle formula. So like I would look at my double angle formulas. Let me scroll down on my notes on my computer so I have access to those formulas. So even I don't have it memorized, but I know that the route that I need to take for this. So if you look at your formulas for double angle, so you have cosine squared minus sine squared. You have 2 times cosine squared minus 1, and then you have 1 minus 2 sine squared. The only one that wouldn't make it really more complicated would be that last one where it's 1 minus 2 sine squared. So that's going to plug in for this, okay? So this just becomes 1 minus 2 sine squared of x, and then I still have the rest of it. So plus sine of x equals 0. This is really nice because this is just a quadratic, and I can solve it and then get my angle values pretty easily. So just rearranging this a little bit, I get 2 sine squared of x plus sine of x plus 1 equals 0. And then I'd probably change these around. So I don't like having a lead coefficient when I'm factoring, so I just multiply everything by negative 1. So this turns into a positive 2, this turns into a negative sine, and this turns into a negative 1. And I just do that only because I have that negative 2 out front, and I hate dealing with that when I have quadratics, so that's why I always do this little trick. All right, now to factor it, so I need numbers that multiply together to be negative 2, add together to be negative 1. So those two numbers are going to be negative 2 and positive 1. So I've got 2 sine of x minus 2, and then also 2 sine of x plus 1. And then divide out the common factor. So 2 and 2 both have a common factor of 2, so these both become 1s. And this is just part of the factoring algorithm that I already know. So if you need some a refresher on factoring, go back to I think it was unit 1 or 2, unit 2 I think, and look at some of those factoring videos. Anyways, so both of these factors end up equaling 0, so I've got sine of x minus 1 equals 0, so I solve it. The sine of x equals 1. And then on your unit circle, if you look at that, the only angle that has a sine that's 1 is going to be pi halves. So that's the one solution you get there. And then for the other ones, I do 2 sine of x plus 1 equals 0. So if I subtract 1, I get 2 sine of x equals negative 1. And then divide by 2, I get sine of x is equal to negative 1/2. And there are two angles that have a sine that's negative 1/2 on your unit circle. And those two are going to be, let's see, that'll be 7 pi over 6, and then also 11 pi over 6. So this is all three of the solutions that are going to work for this initial equation here. And that's it for the extra review. Like always, if you need some extra help, go find your teacher or send an email to them and say, hey, I need some help. I'm in for Hack Lab or whatever you need. And just get the help that you need. This is a tough section. This is a tough unit. This is going to be kind of a tough test if you haven't really been working on any of this stuff. So just make sure that you get the practice that you need. All right, that's it. So now I'll probably just start working on the group work video, and I'll upload that in a little bit.